Hello everyone, welcome back. In this video we're going to take a look how to insert elements in sorted order in a doubly linked list data structure. In singly linked list discussion we saw how to insert items in sorted order in a singly linked list, but this time we are going to see how to insert the items in sorted order in a doubly linked list data structure. If you guys have watched the singly linked list implementation of insert in order or sorted order, here we had a function. So the algorithm is going to be the same with few changes. Here in doubly linked list, since we have 2 pointers, we need to take care of the 2 pointers. Please pause the video and try to add a function in our doubly linked list implementation to insert data in sorted order. No matter in what order the user enters the data, we always want to maintain a sorted doubly linked list, either in ascending order or descending order. I hope you guys have paused the video and tried to implement the function. Say the user want to insert number 4. Say he want to insert number 2, -1, number 6, and 3. So we always want to maintain it in sorted order. We want to have our linked list have -1 as head node, then 2, then we have 3, 4, and 6 as tail node. So let's define a function in our doubly linked list implementation. Here I'm going to write a function public void, let's call it insert in sorted order. This function takes a data in data. The first thing we will do, as usual, we will create a new node using this data. I'll say node, let's call it new node equal to new node of data. Once we create the new node, we will definitely have a tail pointer and a head pointer in our linked list. Initially these 2 pointers point to null. We will say check if the linked list is empty. This newly created node will be our head pointer and tail pointer, so we'll check if this dot head equal to null. If the list is empty, we'll say this dot head equal to new node. Also we'll say this dot tail equal to new node. So say the user want to insert number 4. What we will do, we will create a doubly linked list node having 3 parts, the previous pointer, the data part, and also the next pointer. Let's call it prev. This is the data portion, and also we have a next pointer. Say we want to insert number 4. Initially previous pointer will point to null, and also next pointer will point to null. We will have a reference variable holding the memory address of this newly created object. We called it new node. Say memory manager assigned address 700 to this node. So new node is going to point or store memory address 700. So let's copy this one and insert it in our linked list. As our linked list is initially empty and this is the first node in our linked list, what I'm going to do is I will have the head pointer point to this new node, also the tail pointer point to this new node. Then as we keep inserting in our linked list, there are 3 situations. Either the new data will be inserted before the head node, or it will be inserted at the end of the linked list after the tail node, or it will be inserted somewhere in the middle of the linked list. So let's write code and take care of all these 3 corner cases. Say the user want to insert number 2, we will call the function. The function will create a new node having number 2 with a different memory address. Definitely say this time it has memory address 400. We will check if the data is less than or equal to head.data. Head.data is number 4. Yes, number 2 is less than or equal to number 4. We are going to insert this new data into the beginning of the linked list. So let's do that. I'm gonna copy this and paste it here. We also saw how to insert at the beginning of the doubly linked list. So first we are going to set this new node dot next equal to head pointer. We will maintain a connection like this. We will say new node dot next equal to head, new node dot next equal to head. Instead of null, we will have memory address 700 here. Then we will establish this pointer. This new node is going to be the previous node of this node, so we will have its previous pointer point to this new node by saying head dot previous pointer equal to new node. So instead of null, this time this node's previous pointer will point to memory address 400. Then this newly inserted node becomes the first node in our linked list. We are going to update our head pointer and bring the head pointer here. So I will say head equal to new node. Obviously, once we created the second node, new node is no longer pointing to this memory address. So head equal to new node, head comes here. Say the user want to insert -1. We again going to call the function. The function will have a node with -1 with a different memory address, say this time 300. We will check if the data, which is -1, less than the head.data, which is number 2. Yes, the condition is true. So we are going to insert this new node at the beginning of the linked list, same as we did with the for the number 2. So I'm gonna paste the new node here. We don't have enough space, so let me move it a little bit. New node is no longer pointing here, and we have new node there. So we will say new node.next equal to head. New node.next is going to point to memory address 400. It will point here. Then we will have head.prev equal to new node. So this is our new node. Head.prev is going to point here, memory address 300. Then we will update our temp pointer, head pointer. Head pointer is going to point to new node. Head points here. Say the user want to insert number 6. We will check if number 6 is less than head.data or equal to head.data. 6 is not less than -1. Then we will check if the data is greater or equal to the tail.data, which is number 4. Yes, the condition is true. 6 is greater or equal to the tail.data. We are going to insert this new node at the end of the linked list. So say we have a new node with number 6 with memory address say 900. We are going to insert it at the end of the linked list. Let me copy that, paste it over here. We also saw how to insert at the end of the linked list. We will say new node.prev is equal to till. So we will establish this connection first, and new node dot prev equal to till. Instead of null, this pointer is going to point to memory address 700. Then we will set till.next, which is this pointer, point to memory address 900. Till.next equal to new node. Till.next equal to new node. So we have memory address 900 here. This newly inserted node becomes the last node in our linked list, so we are going to update our till pointer. We'll bring till pointer to this new node. Till comes here. We will say till equal to new node. So let's write code for this one. In the else if block, here we check else if data is less than or equal to this dot head dot data. We will insert at the beginning of the linked list. We'll say new node dot next, new node dot next, not previous, equal to this dot head. Then we will say head dot prev. This newly created node will become the previous node of the head. So we'll say this dot head dot previous pointer equal to new node. Then we are going to update our head pointer, this dot head equal to new node. In the else if block, we'll check if the item to be inserted is greater or equal to the item at the end of the linked list. We'll say else if data is greater or equal to this dot till dot data. We insert it at the end of the linked list, doubly linked list. So we can say new node dot previous equal to new node dot previous pointer equal to this dot till, then this dot till dot next equal to new node, and we finally update our till pointer, this dot till equal to new node. Else, in the else block, we'll definitely know that if the item is not inserted at the beginning, nor it is inserted at the end of the linked list, then it will definitely be inserted at the middle of the linked list somewhere. So say the user want to insert number 3. This time we'll create a node having number 3 with a different memory address, say memory address 1000. So new node is no longer pointing here. We will check if data is less than or equal to head.data. 3 is not less than or equal to -1. We will again check if data or 3 is greater or equal to tail.data. 3 is not greater or equal to 6. Then definitely this 3 will be inserted in the middle of linked list somewhere here, inclusive of inserting at the end of the linked list and beginning of the linked list. We will start traversing over the linked list until we find a position to insert the new node. So what I'm going to do, I will set a pointer to the head node. Let's call it temp pointer. Using this temp pointer, I will traverse over the linked list, and I will check until the next pointer of the temp is not null, and also the data of the temp is less than the newly inserted data. We keep looping and we wanna update our temp pointer. So let me get rid of these codes and write a while loop here. So I'll say while temp.next is not equal to null. While this node is not equal to null, or this pointer does not point to null, we keep looping. At the same time, we check while temp.next.data is less than our data or new data. We keep looping, and every time we increment our temp pointer, temp equal to temp.next, until we find a position to which we want to insert our newly created node. So temp.next is not equal to null. No, temp.next stores memory address 400. Condition is true. We will also check while temp.next.data, temp.next, which is this node, .data, which is this data, is less than our new data. In this case, 3 is our new data. We keep looping. temp.next.data, which is number 2, is less than number 3. Yes, condition is true. We go inside the while loop and we increment our temp pointer. Temp becomes temp.next. Temp points to memory address 400, since temp.next stores memory address 400. So again, we'll check while temp is not equal, temp.next not equal to null. No, temp.next stores memory address 700. It is not null. And temp.next.data, temp.next, which is this node, .data, which is this data, is less than data. 4 is not less than 3. Condition is false. We got a position at which we want to insert this newly created node. So using this temp pointer, we can easily insert a new node at this location. So let me bring this new node here. So we want to insert this new node at this position. Let me copy and bring it here. At this position, we saw how to insert at the middle of a doubly linked list. It should be easy for you guys. So we will first set new node's previous pointer to point to temp. We will set this connection first. Then we will say new node.next equal to temp.next. We set this connection. So after the while loop, here we will say first we will say new node.prev, new node.prev equal to temp. Using this, we set this connection here. Instead of null, new node.prev is going to store memory address 400. Then we were going to have new node.next, which is this pointer, to point to memory address 700. Where we can get memory address 700, we can get it from temp.next. So we will say new node.next equal to temp.next. So temp.next, which is this node, becomes the next node of the new node. So we will say new node.next equal to temp.next. We will set this pointer instead of null. This time new node.next will store memory address 700. Then we will have this previous pointer, instead of pointing to temp, we will have it this time point to new node, since new node will become the previous node of this node. So we will say we will set this link where we can get this previous pointer. We can say temp.next, which is this node, dot previous, which is this pointer, equal to new node. Then we will say temp.next, the next node's previous pointer dot prev is going to point to new node. Then we will make this a new node as the next node of the temp node. Right now this node is the next node of the temp node, so we will make the new node as the next node of the temp. So instead of a memory address 700, this temp.next is going to store memory address 1000. So let's do that. We'll set temp.next, which is this memory address, equal to new node. So we will establish a link like this. These two links will be detached. We will set temp.next equal to new node. Let's say finally temp.next equal to new node. Instead of pointing to memory address 700, temp.next this time is going to point memory address 1000. So everything looks good. So this way we can insert an item at the middle of the linked list. Right now we have a sorted linked list in our implementation. We have -1, we have 2, we have 3, 4, and 6. So let's write code for this last corner case. In the else block, we will have a temp pointer of type node. Let's call it temp equal to initially this dot hit. We will check while temp dot next is not equal to null. Also, we will check at the same time while temp dot data is less than the data the user passes. We traverse over the linked list and we say temp equal to temp.next. Once we got a position at which we want to insert, we can do it using a new node dot prev equal to temp initially. Then we will set new node dot next to point to the next node of the temp. New node dot next equal to temp dot next. Then we will have the temp dot next dot previous to point to new node. We'll have temp dot next dot previous equal to new node. Then finally we will make the newly created node as the next node of the temp node by saying temp dot next equal to new node. I think that's it. Then finally we will increment the size, this dot size plus plus. Let's check the function. So I'm gonna go to the main function and call this insert in order list dot insert in sorted order. Say I want to insert number 4. Then we inserted Control D. We inserted number 2. Then we inserted -1. I think we inserted number 6. Finally, we inserted number 3. No matter in what order we insert the elements, we always want to maintain a sorted linked list, either in ascending or descending. So we have -1, 2, 3, 4. 3 should come here. What's wrong with that? Let's double check. So while temp.next not equal to null, temp.next.data .next.data is less than data. So we have -1, -2, 3, 4, and 6. Let's add a number at the beginning of the linked list. Say I want to add 400. So this 400 should become the tail node, and finally at the end say I want to insert -3. -3 is inserted last. It should become the first element in the linked list. We have a sorted linked list: -3, -1, 2, 3, 4, 6, and 400. Thank you guys for watching. Please don't forget to subscribe and see you in the next video. Bye bye.